In this video, I'm going to discuss about a method to solve a pair of linear differential equation. Okay, so basically, I will focus on a pair of differential equations with constant coefficients. Okay, meaning that you know that so x prime equals to ax plus b. I used to have a g there, right? But it's the same thing. So A is P11, P12, P21, P22, and B was previously it was G, vector G, was G1 and G2. So we will be focusing on the pair of differential equations with all these P11, P12, P21, P22 are constant, as well as the vector of that the G1 and G2, that vector B actually, it is also constant. Okay, so if everything like this and that vector is constant, if vector A and vector Z is constant, then how do we solve? So basically we will focus on how to solve this homogeneous. You remember that what type of system is called homogeneous? If there is like x prime equals to ax, if that the g vector g is 0, or the vector of just constant is 0. Okay, but if we need to solve x prime equals to ax plus b, this is a non-zero vector b. Okay, in that case what we need to do is, first of all, we need to reduce this non-homogeneous equation into the homogeneous form. How do we reduce that? This is how we reduce. Okay, so what we do first to reduce the non-homogeneous into the homogeneous format is basically what we do is we are assuming that this determinant is non-zero. Okay, so when the determinant is non-zero, we can solve this. Okay, so for this to reduce this non-homogeneous into the homogeneous equation, what we do is first find the equilibrium. How do I find the equilibrium? How do I find out that? You do x prime equals to 0, right? By setting x prime equals to 0, then you will get ax plus b equals to 0. Okay, you will do that, and then so what we do after we find out, let us say the solution of this, that is the equilibrium points. The solution of this is the equilibrium point, right? Solution of it is, let's say, vector x equals to x1, x2. Suppose that is the solution of this. So we assume that let me write on x star. Okay, because that x will be the final answer, but this x star is the equilibrium point of this system. Okay, then what we do is, after doing this, we set that after you get that equilibrium point, then we set vector u equals to vector x minus x star, vector x star. Okay, now you take that way. So what is x? X is x1, x2. X star is x1 star, x2 star, and u is, let's say, u1, u2. Okay, then what you can do that is u1 equals to x1 minus x1 star. Okay, and then u2 equals to x2 minus x2 star. That's what you get, right? Because this means what? u1, u2, right? That's the vector u equals to x1, x2, and then minus x1 star and then x2 star, right? That's what you get. You see that? So what do I get then? So you can write that x prime, you see that? So this x star is a constant, right? This is the equilibrium point. This is a constant value. So what do you get then? So what is u prime? Vector u prime will be vector x prime minus 0, right? Because the derivative of x prime is 0. Now what is u prime then? Vector u prime is equals to, what is x prime? X prime is ax plus b, right? So you write a times, what is x? X is u, vector u, minus x star, right? Because ax and then plus b, right? So plus vector b. You see that? Now what happens after that is, you can simplify that, and then you can write vector u prime is equals to a vector u minus a x star vector and then plus b, right? So So what can you write about that is, so u vector u prime is equals to au vector u minus, you can write a x star and then minus vector b, right? Okay, so what is this x star though? So this x star is basically so you can write x star is how can you write that x star? Is x star is the solution of ax plus b, right? So how do I find out that? So how do I write that using that x star here? Is, let me show you that. So here ax vector ax equals negative b, right? So what do you get? Because we found this by, so how do I solve this equation, right? So one way of solving this is you will get two equations and you solve this. If you want to use the matrix method, how do I solve this? Is the solution of this is x star equals to negative a inverse times vector b, right? Because I multiply both side by inverse of a, right? So this is the value of x star. So where we need to assume that the determinant of a is non-zero. Okay, it is non-singular. So to solve this one, the easiest way is we solve those two equations by elimination or substitution method. But if you want to solve this by a matrix method, then you need to subtract b from both sides. You will get ax equals to b. And to solve this for vector x, you need to multiply both sides by inverse of matrix A. So for A to have an inverse, we need, it is non-singular. So I assume that non-singular matrix A, and then if I solve this, x equals to negative A inverse times B, vector B. Okay, now let us plug in that thing here. So you get AU minus A times x star is A inverse times vector B minus vector B. You see that? I mean, you don't need that parenthesis, but it doesn't hurt if you put there. Minus A, and A inverse is just I. So that is vector B minus vector B. That's what you get, vector. So that is just AU. Now you see that? We got u prime, vector u prime equals to AU, which is a homogeneous. There is no separate constant term here. Okay? So this is what you do. Now we solve this one, okay? And again, how do I solve this? We will discuss that later, because I will focus mainly on how do I solve the homogeneous system. And what I was mentioning here is, if the system is non-homogeneous, okay? If the system is non-homogeneous, then you can make it homogeneous by substitution. Okay, so if you know how to solve a homogeneous system, then it is done for the linear system, homogeneous linear system. Then you can do that for the non-homogeneous linear system. So I want to write hence if you want to solve x prime equals to ax plus b, then we first reduce. Let me write down reduce, okay, and then solve. So we first reduce it in the form of u prime equals to AU. We will reduce in that form. Okay, and then what? Then solve this system. And again, how do I solve this system? We will discuss that method later. We will solve this system. At the end, we substitute, because we will be solving for x, vector x, right? What will be vector x? Vector x will be vector u, because after you solve this, when you solve this equation, then you will get the solution u, vector u, right? And then what is vector x then? Because you see that x is u plus x star, right? U plus vector x star. That will be the final answer for this problem. Okay, so let me write down couple notes here. Here is, if the determinant of matrix A is 0, then there will be no critical points, right? Because when we solve the non-homogeneous equation, let's say x prime equals to ax plus b, right? If you're finding the critical points for this, what you will be doing here is you will be taking x prime equals to 0 and solving ax plus b equals to 0 to find out the critical point. But if the determinant of matrix A is 0, then you cannot find the critical points there. So in that case, it is not possible to reduce the non-homogeneous form into the homogeneous form. Okay, that's one of the note. And the next note is, if there are more than one critical point, okay, if there are more than one critical points, then we reduce to the homogeneous form for each of the critical points. So you have to do twice, okay? Or if there are 2 critical points, if there are 3 critical points, you have to do 3 times, and so on. All right. So let us see some of the theorems, because again, as I mentioned, we will jump on the method of solving the pair of first order homogeneous linear ODEs little later. But for now, what I'm going to do is I'm going to present some of the theory behind that. Okay, so let us talk about that. If the first one is, if x1 and x2 are the 2 solutions of the system x prime equals to ax, this is the homogeneous system, right? And again, if the system is non-homogeneous, you can change that to the homogeneous system. Okay, so if x1 and x2 two vectors are the solution of the system x prime equals to ax, then the expression c1 x1 vector plus c2 x2 vector, we call that as a linear combination. Okay, that is also a solution where c1 and c2 are constant. So if they are separately the solution, then their combination c1 x1 plus c2 x2 and in constant c1 and c2, that combination is also a solution. That's what it is saying. So this is called superposition principle. Okay, next is the definition of Wronskian. So let x1 vector is x11 x21, because see why x1 is a vector, because see this x prime equals to ax has 2 equations, right? x1 prime and x2 prime equations. Okay, so whenever you solve it, you will get a vector of the solutions x11 and x21. So let x1 equals to x11 x21 and x2 equals to x1 to x22. Why did I say 2 1 2 2 like that? So this is the first row first column, this is the second row first column, this is first row second column, because we will be combining those two, and then second row second column for the second solution. If they are the solution of x equals to ax, homogeneous system, in an interval I, then the Wronskian of that, what is the Wronskian of the x1 and x2, those two solution is, what do we write is, we denote by w, and then in the bracket x1 x2. If you want to, you can write t here outside. Okay, so w, and then inside the bracket x1 comma x2 equals to, this is the determinant, don't forget that. Okay, this is the determinant of x11 x1 and x21, that's what I wrote, and x1 to x22, that's what I wrote here. Okay, so that will be the determinant of those two solutions. Okay, that is called the Wronskian. Okay, so let us talk about the Wronskian, the use of the Wronskian in the solutions. So suppose x1t and x2t are 2 solutions of x prime equals to ax, and the Wronskian is non-zero. Okay, so we are saying that x1 and x2 are 2 solutions and the Wronskian is non-zero. Then the 2 solutions are called fundamental set of solutions, and the general solution is that. Okay, so in that case, we call that as those 2 solutions x1 and x2. If the Wronskian is not 0, we call that solution as the fundamental solution. And the general solution, how do I write the general solution? We will do c1 and x1t plus c2 x2t. That's what we do. Okay. Alright, so let me talk about one more definition there. Let x1 and x2 be the 2 solutions. So be the 2 solutions of the homogeneous system. We say that x1 and x2 vector are linearly dependent if there exists a constant k such that x1 equals to k times x. That means if one vector can be written as the multiple of the other vector, then those 2 vectors or those 2 solutions are called the linearly dependent. Otherwise, they are linearly independent. Okay. So the next theorem and last theorem, before I jump into the actual method of solving the pair of linear homogeneous first order differential equation, is suppose x1 is x11 x21 and x2 is x12 x22 be the solution of the system x prime equals to ax. Suppose that these 2 are the solution, then x1 and x2 are linearly independent if and only if Wronskian is non-zero. Meaning that if the Wronskian of the solution is non-zero, then those two solutions will be linearly independent. Otherwise, we cannot say anything. Okay, guys? Alright, so these are very basic backgrounds before I jump into the how do I solve this system. Okay, so in the next video I will show you how to solve the system of ODEs, linear homogeneous ODE.